Freelance Word, reach out to me. I'll hook you up with my friend Joe and see if there's anything there that might be able to happen. But with that, let's go ahead and kick things off. Hi, everybody. Welcome to the Hampton Roads.net users group. I'm Kevin Griffin, and I'm joined with my cohort, Drew. Drew, how are you tonight?
I'm doing great. And you, Kevin?
Doing great. For our second year of live streaming things. I think we had a live event in February 2020, and then we had to give it up. I don't remember.
Yeah, I think we stopped in March.
So we've been doing this for a while, but it's been a great opportunity for us to bring on a lot of folks that we meet out in the industry who can't easily commute to Virginia for a 1 hour talk. So great folks like Jeremy Clark. Jeremy, how are you today?
Doing great.
We're very glad for you to join us. I know you're out there on the Pacific Coast, so it's a much shorter commute to come online than it is to fly across country. Yeah,
it'd be a long flight. Yeah,
it would. And we couldn't guarantee the numbers to guarantee that would be a good trip. So we're glad you're here with us virtually. We are currently streaming on the Twitch, the YouTube, and the LinkedIn. If you're watching on the LinkedIn and the video kind of is blurry, go to the YouTube because the video is much better over there. This will also be recorded for the eternity, so you can always come back to it. But we should just go ahead and turn it over to Jeremy because I'm looking personally very forward to Jeremy's talk tonight. And hopefully you all are too. If you have any questions at all, drop them in the chat and I'll politely interrupt Jeremy when appropriate to ask your question. But with that, Jeremy, I'll let you do your own introductions. I'll just give you the screen.
Sounds good. So I'm Jeremy and I do stuff. I do a lot of things in the C# world. I've actually, it's weird because everyone's talking about the 20th anniversary of C# is coming up next week or something. And man, that's a long time. So, and I thought I was coming into the C# world late because I didn't start until .NET 2.0 came out. And that was 2005. So that was a long time ago, even so. So, I won't bore you with things about me. If you're curious, you can hit up my website, jeremybytes.com, or follow me on Twitter at jeremybytes, and you can find more about me and my cats and living in the Pacific Northwest. So I'm in the large town of Sedro-Woolley. We have about 12,000 people. And it's a change because I spent most of my life in Southern California in a city of 300,000 in a metro area of several million. So Jeremy has gone through some transformations in the last 5 years. And but hopefully anyway, it's been good. So if you want to find the slides that I'll be showing as well as code samples and other things, head out to my website, jeremybytes.com. There you'll find a link to this talk, which will take you to GitHub. And you'll find a bunch of stuff there as well as some additional resources that I'll be mentioning as we go. But I'd rather show code. So I'm going to be talking in code most of the next hour or so. So hopefully that works for everyone. And I'm going to be talking about C# channels in particular as a way to solve a particular problem that we have with parallel coding. So with that, I just want to talk a little bit about what channels are in C#, and then we'll dive in and look at some code. We'll look at some different ways of doing things in parallel, different problems you run into, and kind of some of the things that channel can do for us. So channel of T is something that is actually in .NET, and it was rolled into .NET Core 3.0. So that's where it kind of showed up as a thing where you can just put in the namespace and away you go. Bring in a using statement. But before that, it was actually available as a separate NuGet package. Now, I didn't know about any of this because channels is kind of a well-hidden feature that people don't talk about a whole lot. And the way that I ran across it is I was actually doing some learning of the Go language. And Go has this cool thing called channels. It's a channel and it allows you to communicate between two asynchronous methods. So in one asynchronous method, you can write to the channel. In a different asynchronous method, you could read from the channel. And it kind of solves the communication issue once you start doing async stuff. So, I was kind of blogging about it and tweeting about it. I'm like, hey, this is a cool thing. And somebody said, hey, what do you think about channels in C#? And I'm like, what? What do you mean channels in C#? That's not a thing, is it? And I went and I looked and I'm like, oh, it's there and it's been there for a while. And then someone else said, oh, it's been there longer than that because it was actually available as a NuGet package before .NET Core 3.0. So it's actually been available to .NET developers for quite a while now. And it's a way that we can communicate between async methods, like I mentioned. So it can kind of solve a communication issue. And the way we can think of it is it's kind of like a concurrent queue. So there's a concurrent queue out there. It's a thread safe queue, meaning that multiple threads can write to it, multiple threads can read from it, and you don't have to worry about the race conditions and double reads or things like that. But the difference is that channel of T has some added things to it that make it easier to use for the scenario that we're going to look at tonight. First of all, there's a separate reader and writer property. So what that means is that you can be very explicit that I'm writing to the channel in this area, I'm reading from the channel in this area. And then the really smart people that build the compiler can do optimizations around that. The other thing that's really important is that there's signaling built in, because one problem, if you're just kind of using a concurrent queue for communication, how do you know to stop reading from the queue? How do you know that there isn't going to be anything else in there? And that's not something that's built into a concurrent queue. You say, well, I'm going to have to create a variable somewhere that has that information in it. That's something that's actually built in to channel of T. So that's a really cool thing. Now, a lot of times when people hear, communicating, they kind of think, oh, distributed applications, this is going to replace my service bus. No, it's not. This is purely for kind of inside the single application space where I have, again, two asynchronous methods or more than two potentially that need to pass data back and forth across these, kind of amorphous asynchronous spaces that are hard to get data into and out of. So that's what it's there for. So I'm basically going to be showing some a scenario with some code so we can kind of see how this all works and how, especially for parallel code, it makes a whole lot of sense for a lot of the scenarios I've had to deal with. It's not the one size fits all because, there's no perfect tool, but it's actually solved some issues that I've had. So that's kind of what I want to show specifically. So in my experience, I've kind of had a lot of, I have to get data and use data. And so I end up building this little thing. And a lot of times these are tasks. So that top box might be a task that either goes out to a database to fetch some data. It might be calling a web service. It might actually be doing some machine learning processing that's CPU driven. So I have this task that, kind of does this asynchronous process so I don't lock up my application. And then once it's done generating the data or getting the data, I want to do something with it. And so in the case of tasks, I could pass it to a continuation, or if I'm doing an await, I can just do something after that, awaiting that. And I've kind of run into this. This particular thing is pretty common. But then what happens is, especially in my world, I'll end up with a CPU bound operation. And so I want to maximize my use of my CPU resources. So I want to do more than one of these things at a time. And so what I'll end up doing is I'll basically end up spinning up multiple tasks. So I can have, in this case, 6 different things all generating data at the same time. And then once it's done, I can use the data. And running these in parallel, now this is going to run 6 times faster, or a variation of that. And so this is actually a scenario that I've used quite a bit in my code. And the thing is that it works, but there's also kind of a lot of things you have to work around, I guess will be the polite way of saying that. So there's some challenges with this. And this is actually, I want to show what this code looks like so that when we look and see how channels work, it'll be like way more impressive because it'll solve some issues. So I'm going to flip over to code. Hopefully that's okay. And I have a Visual Studio solution here that has two projects in it. The first one is a service. It's called people.service. And this is going to be supplying data for our application. The second one is a console application, and this will be grabbing data from the service. Now, this is intentionally simple, and it's going to be like, Jeremy, why are you doing this on this application? And the answer is because I want to show off the parallel programming steps. After we kind of go through this, I'm going to show you a real world application that I have that uses this scenario. And it'll show that it is actually worth the effort in that case. So I'm going to start by running this application. Now, if you do grab the solution off of GitHub, I have the solution set up. If you look at the solution properties, you can start up multiple projects at the same time when you say go. So you don't have to have just one startup project. So in this case, I have the service set up to start without debugging, and then the console application to start. And that will be with debugging or without, depending on which button I decide to push. So both of these are going to start up at the same time. So I'm going to start by running this, and we'll look at my amazing console application. Now, at the top, there is a list of IDs, and those are the IDs for the data that we're looking at. And then you'll see these items are kind of clicking in one at a time. Okay, so they're clicking in pretty slowly. And the reason for that is that I have an artificial delay built into this. And this is intentional. So the service has a 1 second delay built in. So every time I run a particular service call, it's going to wait for a second before it gives me the data. And that will, simulate some latency for us, since it's all running on my machine to start with. And let's see if I can, oh, wow. Okay. So I just went to Windows 11. So it's doing interesting things when docking Windows. Well, we'll see how this works. Okay. Wow. That's fun. And then to note at the bottom, there is a total time. And so it says it's 9.4 seconds. So there's 9 records coming back. Takes, again, at least a second for each one to come back. Okay, so let's stop that and take a look at some code. So I'm going to start in the console application looking at a person reader class that I have. And these are collapsed to definitions because we just kind of need the signatures to see what's going on here. So on line 16, I have a class. It's a person reader class. And this is what communicates with the web service that I have running. And there's 2 methods on this. On line 21, there's a get IDs async. And that will get me a list of integers that has all of the IDs for the records that are available on the server. And so that's what printed out at the top. Those values 1 through 9 are actually the IDs. Now on line 35, this is a get person async method. And in this one, I pass an ID and it gives me back a single person record. And so I end up calling this 9 times, once for each record. And again, each call to this will take at least a second for this task to complete because of that built-in delay that I have. Okay, so let's take a look at how this is currently being used, and then we'll have some fun with scenarios. So like I said, I have a console application set up, and you can see kind of in the middle, lines 14 or so, I have this, option 1, option 2, option 3. And this is where we'll be playing with our code. Kind of the the outer parts of this on line 10, I call that get IDs async method. So that gives me the list of all of the IDs that I can use. And then for the option 1, option 2, option 3, I pass that list in, and then we'll go ahead and call that other method. And then kind of the rest of this is to facilitate the output. So at the top on line 7, I grab the start time. On line 23, at the end of this, I calculate how long this thing took, and then I output that at the end. So that's kind of the shell of what we're looking at. Okay, so let's look at this first option, which we have now, which is running things sequentially. And I'll just scroll down. That's all in one file, so it's pretty easy to find this stuff. So run sequentially. This is kind of typically what we would do if we're not doing parallel code, but we have something that's returning a task and we need to await it. So in this case, I'm for eaching through all of the IDs. And then on line 34, I call that get person async. And again, pass in the one ID. Now, since I'm awaiting this call, this loop is going to pause right here for at least a second, waiting for that data to come back. And then after the data comes back, we can assign it to that person variable. And then on line 35, we call display person, and that's what outputs it to our console. So this is, kind of the typical thing that we do. If something returns a task, we await it. That's the easiest thing to do. It's really not complicated, but then, or really uncomplicated, I should say. But then what if I want to do more than one thing at a time, right? I really want to think about parallel code because you know what? I can make more than one network connection at a time in this case. Why don't I try to grab more than one item rather than having to wait for one to return until I get the next one? So how can we do that easily? Well, there are things like parallel for each that kind of has its own issues, which I'm not going to get into tonight. But what I've generally done is I've set up a task with a continuation that will allow us to kind of not have to wait in the middle, but still have things going. And that's what we'll do next. And that's really what, if I flip back, this slide is doing. So we'll be setting up a task that will go ahead and grab the data, and then we'll have a continuation that will display that to our screen. Okay, so we'll comment out this first option. We'll go to option 2, and now I have another method called run with continuation. And for this, we'll scroll down again. And this method is not very exciting at the moment. It just has one line in it, which is an await task.delay1. And this is placeholder code. And the reason that I do this type of placeholder code is so that I can have the method signature that I want on line 40. So the thing is, like, if this was empty, then I would get squigglies and it would say, oh, this isn't returning a task. Okay, well, void. And then it'll say, oh, well, this is an async. So that's your signature. But the signature I really want is I want something that will return a task that is also marked with the async modifier. So if you're not familiar with task.delay, it will actually pause operation for, in this case, 1 millisecond. So a very brief piece of very brief part of time in this case. And if you await that, it will wait for that to complete in a nice thread-friendly way, so it's not blocking your main thread. It's kind of like thread.sleep if you've ever used that, but the difference is thread.sleep will actually block your thread while it's doing it. So task.delay works well for that. Now, the reason I use this is it's very obvious that this is code I don't want in my final version. So it's a reminder that, hey, Jeremy, you want to change this. Now, to start with, I'm actually going to copy the code from the first method. So let me just copy that down into our run with continuation. But the difference is I'm going to remove the await. So if I remove the await, now what's going to happen is this for each loop is not going to pause and wait for that get person async to finish. So that means that instead of it going, okay, 1 second, 2 seconds, 3 seconds, it's just going to go as fast as it can. And that's because we're not actually getting a person back here. If I hover over var, then this shows me that this is actually a task. So I'm getting the task back if I don't await it, and it's actually a task of person. So let's be a little more explicit because I like things to be readable, and we'll call this current task. Okay, so instead of awaiting this and getting a person back, we're getting the actual task. Okay, this is great because that means it's not pausing, but I still need to somehow get this person out of it so I can display it. And for that, I'm going to set up a continuation. Now, I am going to go through this fairly quickly. If you're not familiar with tasks and continuations, if you follow the links for this talk on my website, you will find a link to another talk that I do, which is specifically about using task and await and a lot of interesting things with that. And there's a video series and some other things out there. So if you want to brush up on task and continuations, then that is a good place to go. To set up a continuation, I can take this current task and say continue with, and that basically says, okay, so after this task is complete, I would like you to continue by doing something else. And this takes a delegate. In this case, we can pass in a lambda expression that takes a task. And okay, let's do that. And then I'll actually take this display person and put it inside of here. So the idea is that once the get person async is complete, then what I want to do is display the person object that comes back from this. Now I do still need to grab that person object. The task has a property called result in this case. And result, if I hover over it, will show me that this is a person. So this is how I get the payload that's coming out of this task. So I can give this a nice friendly name like that so that it will, so it gives me as the reader an idea of what this actually is. I could pass task.result directly to display person, but then you'd have a little more cognitive effort to understand that. Okay, now I do have one other thing that's happening here, and you'll notice I have a green squiggly happening. And that's because it's saying, oh, well, you have a task here. Are you sure you don't want to await this? It's the compiler basically saying, I think you want to await this. I don't think you want, this is what you want. Well, for right now, I don't want to await it, but I can tell the compiler I don't care about it by using a discard. So I can actually take the task that comes back from the continue with and then assign it to a discard, the underscore. And now I've just told the compiler, I'm doing this intentionally. Now, really what I'm doing is I'm saying, I know what I'm doing, but the compiler doesn't know that I know what I'm doing. Basically, I'm telling the compiler, I think I know what I'm doing. Okay, so this kind of gives us a general idea of what's going on here. Okay, so I call the get person async. That is going to give me a task back. And rather than awaiting that task immediately, I'm going to add a continuation that says, okay, well, when the task is done, go ahead and display the person. And I'm going to leave that await task.delay1 down at the bottom on line 53, just because, again, I'm trying to keep the signature the same. This is not going to do what I want it to do, but I kind of want to take baby steps on this. Okay, so let's run this and see what happens. And we're going to see a couple really interesting things happen. Okay, so what I have is kind of a giant mess right now. The first problem I have is actually right at the top. So I have a total time here which says 0.41 seconds, and it's showing this before any of this other stuff is showing. So that means I'm not actually waiting for the call to finish. So that's one thing I'm going to have to take care of. Now, the good news is it didn't take 9 seconds for this massive data to come back. So that's good. That means I am actually running something in parallel. Now, the bad side of this is you notice the output is in pretty bad shape. So we'll try to understand why that's happening. But let's solve these issues one at a time. So the first thing I want to do is I want to fix this total time. What's happening is that up here in my original main method, I'm doing an await here on this run with continuation, but the that method itself doesn't have anything that says, well, I need to wait for all of these to finish. So basically, this isn't waiting for everything to finish before it continues. So we basically hit line 23 and 24, where we're calculating the elapsed time and outputting it before all of that other stuff has time to run. So to take care of that, what I'd like to do is I'd like to say, okay, I really don't want this run with continuation to exit until all of these tasks are done. And one way we can do this is by using a task.whenAll, which is something I've used quite a bit. It's pretty interesting. So I'm going to create a variable called all tasks, and this will be a new list of tasks. And then what I'll do is I'm actually going to turn this into a variable. I've had enough fun with it as an underscore, but I'm going to say, okay, give me this continuation task that's coming back. And then I'm going to add that to my all tasks list. And apparently I've done this enough time that Visual Studio is saying, hey, I've seen you do this before. So just go ahead and tab through it. I'm still getting used to Visual Studio 2022's completion stuff. So it's fun. So what I'm doing is I'm taking each of these continuation tasks and adding them to this all tasks list. So by the time this for each loop is done, I will have 9 tasks that are part of this. And then instead of doing the await task.delay1, I will change this to task.whenAll, and then we'll pass in the all tasks. So if I await a task.whenAll, that means line 55 is going to pause. So it's not going to move in to exit the method until all 9 of those tasks are complete. And complete could mean error, it could mean cancellation. That's a whole nother story. But it will wait for all of them to finish, is kind of the moral of the story. And so now if I run it, what will happen is down at the bottom, we have our total time, which says 1.41 seconds, which sounds a little more reasonable because, again, it should take at least 1 second because I can't get any data back in less than 1 second. So that's showing me that it is now waiting for those 9 continuations to finish before moving on. Okay, so good. That's one thing fixed. Okay, the other thing has to do with this output. This output is kind of a disaster right now. And the reason for this is that my display person method that I have here is not thread safe. It's not thread aware. It is not thread friendly. Let's go down and take a look at that and understand why it's not thread safe. So in this display person, there's 4 calls to console.writeLine. And what's happening is that this display person method is being called several times at the same time or really close to the same time. So what's happening is that first record comes back and it wants to have 4 write lines. Okay, the little line at the top, and then the person, and then the start date, and then the rating. Now, the problem is that the second item comes back at pretty much the same time, and it calls display person at the same time. And basically, these write lines are getting interleaved. And so if we look at the output, that makes it makes a lot of sense, because if we look at the top, wow, that one wasn't as bad as most of them. Let me run that again. Okay, and so the fun thing about this is it'll be different every time because it's parallel and non-deterministic. But you can see I have 2 straight lines at the top, and then 2 names, and then 2 dates, and then 2 ratings, and then they're kind of mixed together. I'm not exactly sure which dates go with which records. So that's what we're seeing. Now, I could try to make this display person thread safe, but kind of what I want to show when we look at how channels work is that I don't have to worry about that anymore. So rather than making this thread safe, I'm going to come up here and do something I hate doing, but I find myself doing a lot, and that is adding a lock. So if you've never added a lock, good for you. Um, generally, if you have to add a lock in your code, it means that something's not ideal, but this is what you do to get it to work. So that's my experience. So what the lock does is it basically sets up this block of code that says only one thing is allowed in this block at a time. So the first record to get back is allowed inside this block, and it can call display person. Now the second item that comes back at the same time, it will hit this lock and say, oh, well, I have to wait because there's a lock on this. Someone else is using this. And once that first item is done, then the second item will be let in and it can do this. Now, this does cause a performance hit. So that's why you always kind of have to cringe a little bit when you do lock, because it's like, okay, I'm purposely messing up performance to get the output that I want. Depending on your scenario, that might be just fine, but it is something to be aware of. But with this lock in place, now when we run this, ta-da, we'll actually see the data coming out the way we expect it. So at the bottom, again, we have 1.4 something seconds for the total time. And then as I scroll up to the top of this, we can see that we have those 4-line blocks for the right line outputting each of these. Now you will notice they are not in numeric order. So looking at the IDs, it goes 2, 9, 3, 5, 4. That is non-deterministic. And again, that's just one of the joys of programming in parallel. And if order is important to you, then you get to do other things, which we're not going to talk about tonight. But this is kind of a scenario that I've come across quite a bit. And again, kind of going back to our slide, it's okay, I have a task that takes a while because it's either making a database call or a service call or doing some heavy CPU calculations. I want to do more than one of these at once so I can optimize, my efficiency to get this completed faster. So I'm going to create a whole bunch of these. And, kind of once that task is done, I'll have a continuation that does something with that data, stores it, shows it to the user, sticks it in another database, outputs to a file, depending on what we're doing in the scenario. Now, we did see kind of a problem is if the using data part is not thread safe or thread friendly, it can cause issues, right? So, and I've async is fun, right? I just love async. Okay, so this is one way of doing it. And this is actually the way I did a lot of parallel code before I learned about channels. Let's take a look at a different model of how we can do the same thing. And this is something where channels is going to help us out. And this is a pattern known as the producer-consumer pattern. So, excuse me. The idea with this is that I have one or more producers that can produce data, and they can do this CPU intensive or long running process. And I can run a whole bunch of those in parallel. And so let's go ahead and pick some of these off. So these producers are producing data, but instead of doing something with that data immediately, I'm basically dropping it into a funnel. And in this case, that funnel and, well, kind of the funnel and the conveyor belt in this particular diagram is the channel. So as soon as the producer has produced something, it sticks it into the channel. And then on the other end of the channel, we have a consumer that can read the data off of the channel. And the difference here is that the consumer can do it in its own fashion. So in this case, I have multiple producers that are producing data and putting them into the channel, but I just have one consumer on the other end. And what this will do is it will kind of solve that problem of trying to call that display person multiple times at the same time and just kind of do things one at a time. Now, just so you know, channels do not say you only have to have a single consumer or reader on the other end, you can have as many writers putting data onto a channel and as many readers pulling data off of a channel as you want. And again, it is all thread safe. So if you have multiple consumers pulling data off of a channel, you don't have to worry about two of them accidentally grabbing the same record because they're doing it at the same time. The channel takes care of that for you. So just a lot of really cool things. Okay, so here's kind of the overall flow that we're looking at. And really, the idea is that producers and consumers can communicate asynchronously with a channel. This is kind of the purpose of why we have channels. And then, as far as channel of T is concerned, there's basically 4 major operations that'll help us get this done. So the first is creating a channel. So we need a channel that we can put stuff onto and read things off of. Next, we're going to need to write to the channel. So our producers will produce data and then write it to the channel. And then we'll also, I should flip these last two. We'll also have something reading from the channel. So our consumer will be reading data off of the channel. But then I talked at the beginning about signaling and how it's really important to let somebody know, hey, there's not going to be anything new on this channel. And that's what marking the channel as complete is. So what we can do is after we're done writing to the channel, we mark it complete and basically say, there's not going to be any more writes. And then whoever's reading from the channel can continue reading until the channel's empty. But then when the channel's empty, they'll know that there won't be anything else. And so we can stop listening. And that's a really key feature, which I have found out the hard way. I'll just say I found it out the hard way. So let's see if we can put this code into place. So let's flip back and let me shut down. Let's see what I've got running here. Is this still running? Yes, that's still running. Okay, so we'll go back to our console application, scroll up to our main method, and instead of having a run with continuation, we're going to go to run with channel. Okay, and if we scroll down to this one, option 3 looks very similar to what option 2 looked like when we started. Okay, so I'm just going to put some comments in so we can keep track of where we are. So the first thing we're going to do is create a channel. Okay, so that'll give us a place to put things. Then I'm going to start the consumer. And sometimes this is called a listener. So the producer consumer pattern is kind of a common name for the pattern, but sometimes we call this a listener because it's listening for data. And then I will start the producer. Now, the reason I start the consumer before the producer is so that it's there and ready to go. So basically, I can say, okay, fire up the consumer. And if there's any kind of startup process that consumer has to go through, it'll be done and ready and listening to the channel before the producer even starts. So as soon as the producer sticks something into that channel, the consumer is going to be there ready to pull it off immediately. So there won't be additional delays. So I generally like to start the consumer first, not required. And then what we'll do is we'll wait for the producer to finish. And then we will wait for the consumer to finish. And I am not typing too badly this evening, so that's good news. Okay, so let's run through these steps. First, let's create a channel. So I'll create a new variable called channel. Now, in this case, we're not going to new up a channel. Instead, the channel class has some static factory methods that we want to use. Now, the first thing I'll do is I'll just type in channel, and you'll notice I'm not getting the code completion or IntelliSense on this. And that's because I do need to bring in another using statement for the namespace on this. So I'm going to hit Control Dot because I like letting Visual Studio do things for me. And it says, oh, well, channel is in system.threading.channels. Would you like me to add that using for you? Of course I would. And so now that's at the top of my file. And this channel class is now happy. And now if I say dot, we do get IntelliSense and code completion. And there's 2 create methods in here. There's a create bounded and a create unbounded. I'm going to start with create bounded, just to talk about what that means. So when we talk about the difference between a bounded channel and an unbounded channel, a bounded channel is limited to the number of items that it can hold. So for example, if I say my channel can hold 3 items, then if as soon as there's 3 items in the channel, if someone tries to write a 4th item, that write will fail. And depending on how we do it, it might fail or it might wait for space to be available. And I'll talk about that a little more when we talk about writing. Now, as soon as somebody reads something off of the channel, now there's space for a new item, and so something else can pop in. And so if we have a bounded channel, we can use it as a way to limit the amount of memory we're using for the channel if we have large objects, for example, or as a kind of throttling. But it's not something that really fits with our example tonight. So I'm just kind of pointing that it's there. Now, both create bounded and create unbounded do have generic type parameters. So we do need to tell it what kind of objects we're going to put into this channel. So in this case, we'll say person. And of course, you can just say object since it's C# if you want to put whatever you want in there. But again, kind of the more strongly typed things are, the better the compiler does as far as optimizations and whatnot. So knowing what that is usually helpful. And one of the overloads for this create unbounded is a capacity. And again, how many items will this channel hold? I'm going to say 10. And like I said, that's a bit of a cheat because I've only got 9 items. So we're not gonna worry about this evening. But I do want to point out that this is a distinction that you get to choose. Okay, so now we have a channel that's created to hold person objects. Let's go ahead and create a producer. So even though I'm going to start the consumer first, I'm going to actually write the code for the producer first. Okay. So I'm going to have something that ends up with a task, which is called producer. And for this, we will call, we'll call it produce data. So I'll create a method called produce data. And this will take the IDs that we have coming in up at the top on line 64, our parameter, and then the channel. Okay, so I'm going to take the IDs and the channel and have a method that will work with both of these. But I'm not actually going to pass in the entire channel. Instead, what I'm going to do is I'm going to pass in the channel's writer property. So I mentioned earlier that channel has both a reader and a writer property. And you can pass the entire channel in and your method will still work. But the thing I like about the discrete properties is that now the intent is clear. So in this produce data method, I am going to be writing to the channel. I will not be reading from the channel. So this method will only put things onto the channel. So I like this because as a human, it makes it very clear what the intent is. And then as someone who trusts the compiler builders to do the right thing, they can also do optimizations based on that. So they're like, oh, if you're just using the channel writer, then, we don't have to worry about the reader parts and we can do all these optimizations for you in the background. And I love not having to worry about that kind of thing. Okay, now this method does not exist. So I'm going to hit Control Dot and let Visual Studio generate this method for me. And it's right down here. So we'll just scroll down and take a look at it. Okay. And again, the signature is the one that I wanted. So it does return a task. It takes a list of integers for the IDs as a parameter, as well as a channel writer. And notice that the channel writer is a separate type. So there's a channel writer type that is associated with that writer property. Whew. Okay. Am I talking too fast or am I doing okay? Because I feel like I'm talking really fast. Okay, no response. I'll take that as a keep going, Jeremy. Okay. Now, just like with my other methods, I'm going to come up and steal my sequential method from the top. So we'll go ahead and paste this in. Instead, but I will not be calling display person. Okay, and let's go ahead and add an async modifier here to make this happy. Okay, instead of displaying the person, I'm going to take that person object and put it onto the channel. Now, the channel writer has quite a few methods that we can choose from. There is a try write, there is a write async, and there is a wait to write async. So the reason why there's a distinction on these, so I'll just use try write as an example. So if I use try write and say try to write this person to the channel, if that channel is full, meaning it's a bounded channel that reached capacity, then try write will fail. It'll return a false and say I was not able to write your data. Otherwise, it will return a true and say yes, I was able to write your data to the channel. If I say wait to write async, this is a little more complicated, but what it does is it returns a task that I can await. And so if the channel's full, then I'll get a nice little pause until there's space available and I can write to the channel. Um, I'm not going to be showing an example of that this evening. Instead, I'm going to use write async. And write async will do kind of what you expected to do. It has the magic async word in it, which means we can await it, and it's going to be doing that, nice magical threading stuff that task and await do for us that we don't have to worry about. And this is a scenario where with the write async, if the channel is full, again, it's reached capacity, then this will pause until there's space available. So it won't return with a failure. It'll just wait until there's space available. Now, theoretically, it could wait indefinitely, which isn't good, but it's what it is. Okay, so this is what I want to do. I want to call the get person async, get the value back, stick it onto the channel. But I have a huge problem with this for each loop. So the huge problem with the for each loop is that this is basically the same code that I had in the run sequentially method. So in this for each, as soon as I hit this await, this loop is going to pause. So this loop will take at least 9 seconds to complete. And that's not what I want. I want this to run in parallel. So I'm going to do what is known in the technical world as a cheat. And if you deal enough with async, await, and task, you will find yourself cheating quite a bit to get the thing that you want to work. Okay, let me show you what my cheat is. So my cheat is I'm going to take the insides of this for each loop, highlight it, and I'm going to hit Control Dot in Visual Studio to extract this to a separate method. So I'm going to say, okay, let's put this into another method, and we'll call this, how about fetch record, since I'm getting an individual record. And I'll scroll down a little bit so that both of these are visible on the screen. So this fetch record method, and then I'll do the, I don't like that it does this. I don't know if you knew you could do this easily in Visual Studio. I'm going to hit Control Dot, and then there's a change signature option here. And with that, I can flip the order of the parameters. And I like that. Because since this is list of int channel writer, I kind of want this to be int channel writer so that they line up. That's just my brain trying to make things line up. So even though the original one was flipped around, that's a real easy way to flip them the way I want them. Okay, I give out as many tips as I can as I go through these things. Okay, so now what I've just done is I've taken this inner parts, put it into a separate method that now I no longer have to await. So I don't have to await this in the fetch record. Now, again, I do have the squigglies that say, hey, I'm pretty sure you want to await this. Are you sure you know what you're doing? Well, in this case, yes, I don't want to await this. I want this for each loop to run as quickly as possible. Generate all 9 of these tasks and then go on with your life. So that's what I wanted to do. Now, again, I want to keep the signature for this method. So I'll put in my cheat task.delay 1. And again, the reason I like this is because it's very obvious that this is something you don't want to do in your code. So it kind of sticks out as a placeholder. I think I saw something go by in the chat that there's another way to do this, to do, a little cheat that will keep the method signature. You could return a value task or some other things. In this case, I want to be able to await something so that I can keep the async modifier in there, and then I want it to return a task. So that's why I tend to use this format. And again, just one of those things. Okay, now I actually know that this is not going to work as intended, but it's enough code for now. So this is enough for us to move on with. So the idea is that, again, I'm going to run through this for each loop very quickly, basically kick off these 9 tasks, and each of these tasks will go out, it'll make the service call, and then when the data comes back a second later, it's going to write it to the channel. Okay, and that's really all I kind of care about at this point in time. Now I'm going to care about some more stuff as we go, but this again will get us started. Okay, so there's our producer. Now I want to start my consumer. Okay, so what's my consumer going to look like? Well, we'll call this show data because that's what we're going to do. We're going to display the data on the screen. And this will take the channel reader as a property. So we'll have the channel reader, so I can pull person objects off of the channel, and then we'll use the same display person method that we were using earlier. And again, I'll come over here and control dot to generate that method and scroll down. And it actually has the signature I want. So again, channel reader of person. And this also returns a task. Okay, reading from a channel. There are a lot of different ways to read from a channel as well. And we'll just kind of skim through a couple of these and I'll tell you what they do. Okay, so there's a try read. Okay, and what that'll do is it'll look at the channel and say, hey, is there an object? If there's an object, give it to me. So if the channel is empty, try read will return false. Okay, it did not succeed. If there is an item available to be read, it will return true. And you'll have, in this case, you can see in the signature here, there's an out parameter that holds that actual value. There's also a peek. So just like with a queue, there's something where you can peek and say, let me look at that item, but don't pull it off of the channel. Okay, so I just want to look at it, but leave it there. So there's a peek in addition to a read, and try peek, very similar to try read, except it would leave it there. And then kind of some of the other ones down here, there is a read async. And read async will read one item off of the channel. And if there's nothing on the channel, then we can, again, this is kind of like the write async. We can await this and it'll just wait for something to be there. So we can call read async. If the channel's empty, it will pause very nicely and friendly. And then as soon as there's an item there, then things will continue. Now, I don't want to read them all one at a time. I want to read everything I can get off of this channel. And that's what read all async does. So read all async gives us one of these cool things that we got in C#8, which is an Iasync enumerable. And this is something that a lot of people aren't familiar with, or maybe haven't heard of, or haven't encountered. This is a perfect scenario for Iasync enumerable. So you're going to learn about it a little bit tonight if you don't already know. So what is an Iasync enumerable? It's a combination of two of my favorite things, Enumerable and async. Okay, so Enumerable is an implementation of the iterator pattern. And what that just means is that I have an object that I can say, get me the next item, get me the next item, get me the next item. And what do we normally use for that? A for each loop. So for each allows us to say, hey, give me the next one, give me the next one, give me the next one, keep giving me items until there aren't any left. And so for each, I love for each. Now, the async part means that if there is not an item available, So we've, the channel is empty in this case. We can do an await to wait for another item to be available. So with a normal Enumerable, if there's no item available, it will exit out and your for each loop will exit. But with an Async Enumerable, it will potentially just pause and wait for the next item, and potentially forever, which is what we'll see in just a bit. Okay, so Iasync Enumerable is pretty neat. So let's do a for each, and we'll pull persons out of, let me just be really explicit here. We'll pull person objects out of this Iasync Enumerable. Now, not equals, that should be an in. Come on, Jeremy, you know how to do a for each loop. Now, this is not happy because it's saying, well, you can't just for each on this. What you actually do is you await for each on it. And since I add in an await, I'll need my async modifier on the method as well. And so again, since we're creating the consumer first, this is going to kick off before the producer is even doing anything. So this for each loop will start and say, oh, this channel's empty, let me wait. And then the producer, we're going to start the producer, and it's going to start going through and producing its items. And again, it'll take at least 1 second before that first one will come back. And as soon as that one comes back, this for each loop will start going to town. It'll say, okay, give me that one, give me that one, give me that one, give me that one. And then inside of this, we can call display person and just use the person that's coming in this for each loop. Okay, I think we're getting close to being able to run some code. Okay, so let's fill in these other steps. Wait for the producer to finish. So we'll just await the producer here, and we'll wait for the consumer to finish. So we'll await the consumer here. And then we'll cross our fingers and press the go button and see that it doesn't quite work the way we want it to. It seems hopeful. So I did get all 9 items, and it took, a second-ish. It did not take 9 seconds, but I don't have a total elapsed time anywhere. So, I don't have it at the top, like, we had that problem with our task and continuation, and I don't have it at the bottom. And that's because my application is still running. This is not complete. And it's exactly what I was talking about with this read all async. It's going to wait for another item. So our producer put 9 items onto the channel. Our consumer pulled 9 items off of the channel, and now it's waiting for a 10th one. Now, there isn't going to be a 10th one, which is why our application is basically hanging at this point. Now, it is hanging in a nice thread-safe way, so it's not blocking any threads, but it is never going to complete. And this is where the signaling part comes in. So what I need to do is I need to tell this listener, this consumer, okay, you can stop now. And basically, we have to tell this read all async that there will be no more items. And that's where we will mark the channel writer as complete. So we'll mark the writer as complete, and it'll say, hey, there's no more items. And as soon as something is marked as complete, this read all async will it'll keep reading all of the items it can. So it will continue until it drains the channel. But then as soon as the channel's empty, if it's marked as complete, then this for each loop will exit. Okay, so there aren't going to be any more items. I can exit out of this. We are done. Okay, now the next question is, where do we mark the channel as complete? And there's a lot of options. I could try to figure out how to do it somewhere in this method where we're waiting for the producer and things like that. Generally, I like to put it as close to where I'm using the channel writer as possible. So in this case, I'm using the channel writer inside this produce data method. So this is where I want to mark the channel as complete if I can. Now, I often say close the channel because that's the terminology I learned from Go. And so that's stuck in my head. But in C#, we mark the channel writer as complete. Okay. So let's do that. Okay. So the channel writer has a method called complete, and we just need to call this method. Okay. Um, let's see what happens. Okay, now we run it, and our application is really not doing what I want it to do. Basically, it completed immediately. Okay, so my total time is less than a second, and I'm not seeing any of my data at all. And so we're kind of running into that timing issue again. This for each loop will run really fast, kick off those service calls, and then we're going to mark the writer as complete. And what's going to happen is a second later, that data is going to start coming back, but it's going to say, "Oh, well, I can't write to the channel because the channel is marked as complete. I'm not allowed to write to it anymore." So our data is never making it to the channel because we're marking it as complete before we've even written to it. Okay, now what? Well, you know what? I'm going to use that same technique we used when we were using task and continuations. So let's create an all tasks variable, new list of tasks. And then here, how brave are you feeling? I'm feeling kind of brave. I'll just be explicit to show how this works. Task, current task. And then we will take all tasks and add our current task. And then here we will do await task.whenAll on our all tasks. And then we can mark our writer as complete. Since I actually have an await in here now, I can get rid of my await task.delay1. So placeholder gone. Yay. Okay. So now what will happen is this for each loop will still run very quickly. But then we hit line 102, and it's actually going to wait until all of those tasks are done before we mark the writer as complete. Okay, that's feeling pretty good. Let's cross our fingers and run and see what happens. Oh, I think we have what we want. So if we look down at the bottom, our total time is 1.4 something seconds, which is what we would expect in this case. We do actually have all 9 records coming out. And again, they are in a non-deterministic order. So this will be potentially different. I won't say different every time we run it because there's only 9 items. There's only so many combinations of those, but it will be non-deterministic. And yeah, so it's doing what we want. Now, there's an important thing that we did not have to deal with in this scenario, and that is we didn't have to deal with the threading problems we had with our display person method. So here in our show data method on line 84, our consumer, we call display person, but because we're doing this inside a for each loop, we're only going to be doing this one item at a time. So we're going to pull the first item off the channel, display it, pull the second item off the channel, display it, pull the third item off the channel and display it. So we don't care how fast those items are going onto the channel or how many go onto the channel at the same time. All we care about is they're there. We can pull them off one at a time and call display person. So for a scenario like this, it works really well. And yeah. So let's come up and just review, excuse me, what we have in our kind of entire process here. So again, we start out by creating a channel. I'm going to get rid of these comments now that this is filled in because it'll make it look a bit easier to read. So we'll create our channel, and there's our create bounded channel. Then we will start our consumer. And again, that's our calling our show data method that returns the task that starts listening to the channel. Then we will start our producer by calling the produce data method that will start calling the web, start making those web service calls and then writing to the channel. And then we'll wait for the producer to finish, wait for the consumer to finish. And I don't need this await task.delay1 anymore. So placeholder's gone. And I like that. Now, if you start getting into this and thinking about it and looking at it, there's some things we technically don't have to do. Technically, I don't have to wait for the producer to finish because the consumer will not finish until the producer is done and has marked the channel as complete. So technically, I do not need this. But for my peace of mind and for me as a human who's trying to understand this process, I like to have it in there because to me, it's very kind of clear as far as what steps we're doing, even though this one might be technically unnecessary. I find it easier to read. Okay, so this is kind of the simple scenario, and again, it is faster. So instead of taking 9 seconds, it takes 1 second, which is good. But at the same time, it's kind of a contrived scenario because in a real scenario like this, if I wanted to pull 9 records off of 9 records from a service, I'd probably do it in a more batch processing type way. But it gives us an idea of how this process works. Because now I want to show you a real world scenario. And real world is for a very loose definition of real world, because this is my hobby project where I call it discount machine learning, which is basically, I did some machine learning code that did some handwritten digit recognition. And that's based on a book and some tutorials that I was going through. Now, what I didn't like about this particular, let me go ahead and start this without debugging. The debugger really gets in the way of this because this is a CPU bound operation. Let me just go ahead and kick this off so we can have it running while I'm talking. Now, what I didn't like about the tutorial I was going through is basically it was looking at bitmap data and trying to figure out what digit does this represent. And for the tutorial, when it got to the bottom, it would basically say, oh, well, using this algorithm, it was 92.4% correct. Using this algorithm, it's 95.2% correct. And that was really unsatisfying to me. So I wanted to know, what were these algorithms getting right? What were they getting wrong? So I created a visualizer. And that's what this application is. So this application is a visualizer for handwritten digits. The ones that are red are ones that are incorrect, and we can hover over them and look at them. So here's our image, which to me looks like a 9 as a human, based on the algorithm, which is a very simple, naive algorithm. It thought it was a 7, and you can see the actual value here is a 9. So this lets us kind of look at what it thought things were. And this one makes a little more sense. Okay. Yeah. As a human, I would guess this is a 4, but I can totally see why the computer thought this was a 9. So, sometimes it's more obvious than others. And yeah, here's the one. Somebody does the European ones. So if we have people in Europe, Americans don't write it like this, with the little slash. And so again, the machine algorithm that's very naive got it wrong. Now, you'll notice it took a while for this screen to fill. It took 43 seconds for this to fill. And this is actually a CPU bound operation, which means it's using my CPU resources. Now, the way it's set up right now, it's doing things sequentially. And that means it's only using one of my cores. And that's why it takes so long. And each record takes about a quarter of a second-ish to calculate based on the data sets that I have and things like that. So it takes 43 seconds in this case to process 375 records. Now, you can imagine when I first did this, I was thinking, okay, this is great, but I need to run this a lot of times because I really wanted to run algorithms side by side, which is why there's kind of two halves to this application. The left hand is blank for the moment. And so running things sequentially just wasn't viable because it takes too long. And on this particular machine, I have 16 virtual cores. So let me take advantage of that. And let me show you what that code looks like. First of all, I will uncomment some code, and this will add a user control into the WPF application. Not going to talk about all of that stuff. But let's look at that control itself. So to kick off the calculations on this, there's a start method on the user control. And this code looks pretty familiar, doesn't it? It looks exactly like what we saw in our little insignificant application. So on line 74, create the channel. In this case, I'm doing an unbounded channel. On line 76, I'm starting the consumer, which I call a listener in this case. Next, start the producer, wait for the producer to finish, wait for the listener to finish. If I look at what the listener does, this will also look very familiar. So on line 43, we have the listen method, and this is doing an await for each on the read all async. So we're going through all of the items that are coming through in the channel. And then line 47 is a create UI elements method. And this would be equivalent to the displayed person method that we had in our other example. But instead, what this is doing is it's taking bitmap data, turning it into an actual bitmap, taking the calculated data, putting it into basically a little grid next to that, and then calculating some other things with the actual, doing the red background if it needs to do the red background because it's wrong, and then sticking it all into a WPF list box. So that is all UI thread stuff in this case, since this is a desktop application. But we can see the process looks very similar to what we saw. For anyone who's done desktop programming and has to protect the UI thread, the nice thing about this, again, is since I'm doing this for each, I'm pulling one item off at a time. This create UI elements is running on the UI thread. And so this part will run sequentially once the channel has data in it, but doing it again, kind of in a way that keeps our application from locking up, which is what we want to avoid. Okay, so the listen looks very similar to our show data method from our other application. The produce looks quite a bit different, but it does have the same basic features that we saw in the other one. I'm going to kind of skip over a bunch of stuff and come back and talk about why it's doing it. But let's look at the important bits. So line 62 has a recognizers.predict function. And this is that CPU intensive function that, again, takes a quarter of a second to complete based on the current data set and whatnot. Now, this is not an asynchronous method. So we're not awaiting predict because it just returns a value. It doesn't return a task. And so in this case, this is our long running process. And then, so line 62 is our long running process. Line 63 kind of puts that into a different format. It massages the format that we need for our channel and for our create UI elements. And then on line 64, there's an await writer.write async. Okay, so the same basic things. We're doing our long running process and then writing it to the channel. Now, the things that are a little bit different from this is since the predict function is not asynchronous, it doesn't return a task. What I've done is I wrap this whole thing in a parallel for each async. And parallel for each async is actually something that's new in C# 10. So this is a brand new thing. And that's good because parallel for each works in some scenarios, but as soon as you await something inside of a parallel for each, it falls over. So it makes it inconvenient to use because you can only use it for things that you are not awaiting. Now, parallel for each async, which again, brand new, well, since November at this point, but fairly new. This allows us to await things in it. So on line 64, where I'm awaiting the writer to write async, that's perfectly fine. It's not going to make this whole thing fall over. The other thing that we can do with a parallel for each async is on line 56, you'll notice that I'm awaiting this. And that means that this block of code is not the next line of code in our produce method will not run until this entire parallel for each async loop is complete. So you'll notice on line 67, I'm marking the writer as complete. So this entire parallel loop will finish, and then our next step, line 67, will run mark the writer as complete so the listener can stop listening. So again, a little bit different since we're not dealing with async methods, but and then doing this, I won't show that code, but doing this in .NET 5 before parallel for each async existed was a lot more challenging. I'll just leave it at that. You can look up the code online if you're really interested. But let's just run this. Oops, I just hit start with debugging, which you don't want to do that because the debugger really gets in the way of this CPU bound operation. Okay, so we'll click go. There'll be a couple second pause as it's loading up the data sets. Okay, and as soon as I say go, it's going to start running that parallel one with the channel. And that's quite a bit different, isn't it? Yeah, look at that. 5 seconds instead of 43 seconds. And so it's actually using all of my cores. And actually, it's technically not using all of my cores because I throttled back the parallel loop to 12 instead of 16 on my machine, so that hopefully there'd still be some CPU resources available to keep the stream going. And so hopefully that worked. It appears that it looked. In my other monitor that's showing the stream, it looks like that worked. And so, I think this is really cool. And again, I had written this parallel code before I knew about channels. So I had used the task with the continuation previously and gotten it to work, but I did need some locks because again, I'm writing to the UI thread. I can only have one thing on the UI thread at a time. So to prevent deadlocks, I had to have some locks around some things. And again, something I was willing to deal with to get the output that I wanted. And there were, again, kind of some other interesting things that went on with that. I'll just kind of leave it at that. Okay, so again, kind of the major operations with the channel. You can, create the channel, write to the channel using a producer, read from the channel using a consumer/listener. When you're done writing, mark it as complete so the listener can stop listening. It's pretty cool. And then if you're interested, I won't go through this, but the rest of the slides are basically the things that I talked about. So, what the create bounded versus unbounded means, how to use write async, marking the channel as complete. So, there's some things out there for your reference if you're interested. This is the long link to the code. The shorter link is if you go to jeremybytes.com, my website, then actually kind of right at the top, you'll see a link to the Hamptons Road.net user group. And that'll take you straight to this GitHub repo. So you don't have to try to write this all down. And then, so from my website, it's easily linkable. And let's see what happens if I go there. Let me go there and I'll show you. Last step. Okay. Boop. Okay. GitHub. So it does have the sample code, so the people demo, as well as the digit display. So the discount machine learning code is in there. The slides are in here as well. CSART channels.pdf. And then there's also some instructions on how to run the code. This does all work from Visual Studio Code if you want to just run it from VS Code. This the people one is cross-platform friendly, so you could run that on Linux or Mac OS if you want. The digit display one, that is a WPF Windows desktop application, so that will only run on Windows. And then I mentioned some, and then if you want to dive deeper into my discount machine learning, there's a separate repo that is linked here that has articles and all kinds of stuff about that. And then I did mention additional resources. So this I'll get back to you task await and asynchronous methods in C#. If you want to learn more about task and continuations, cancellation, exception handling, all that kind of stuff, go out there. There's articles and video series and all kinds of fun stuff like that. So I didn't see a whole lot of questions come in. I probably saw some that I wasn't very good at answering. But it's actually, I get overexcited about this because to me, this is really, really cool.
This is one of those toys where now everyone wants to go rewrite a whole bunch of code. It's like, oh, I have a use case for this. Let me go rewrite this entire part of our application just to squeeze every little ounce of performance out of it. That's why I was sitting here thinking, I'm like, ooh, I have a use case where this might be really useful. I might need to go rewrite some code.
Yeah, and just as a little sidebar, why this was interesting to me is in Go, they have kind of a different way of handling async methods. And there's no like task of T result like we have in C#. So the only way to really get data out of an async method is to use a channel or like another shared variable or something like that. So channels are kind of required for reasonable communication in Go. And in C#, it's an awesome like other option that we can use. Okay, I do see a question. Is there a downside to channels? I would say the downside would be if your scenario doesn't match kind of what I showed, you know. So if you have, I think they're most useful for parallel code. You can technically use them for sequential code as well for communication, but they kind of really shine in the I'm managing multiple threads at both ends with everything being friendly. As far as it's hard to say for drawbacks because I've been more focusing on what scenario are these good for so that I could try them out. And so I really haven't explored what scenarios this would make worse. And that's actually something I should probably think about.
Good thought.
Great. You guys gave me homework. Homework. Okay, now I have to look into that.
Well, maybe do you get any benefit if you're running this? Like you were running your handwriting example on a multi-core system, and you got a very good response from that. But what about a case where maybe I'm using something like Azure Functions or some like mono processor instance where I don't have 16, 32, or 64 cores available to me. I'm limited to one core. Do I get the same sort of benefit from a channel as I would if I was just doing traditional async?
I think it would be really limited because where it really shines is with parallel.
Yeah.
And what you've just described is a situation where parallel doesn't work, you know, and that would be regardless of what approach we took to parallel. But you could definitely use channels. Well, see, the thing is, because, you know, task generally is like task of T, right? We have an easy way to get something back from a task. And if we await it, we get that back really easily, right? So putting a channel into that kind of single, I don't want to say single threaded, but kind of one at a time sequential processing scenario is probably just going to make it more difficult to read and follow.
There's a question here. Did you run into problems implementing this in Go that caused you to look at a C# solution?
So that's actually an interesting question because I don't know if this is a talk or a video or what, but I got started with Go and then and Rust in the past year and a half, just out of curiosity. So what I've done is I've actually taken my so that digit recognition thing, the WPF application, also has a console version. And the console version spits out really bad ASCII art, but it is cross-platform. And so Windows is not required for that. And so what I've done is I've actually created a Go version of that, as well as a Rust version of that, and a C# version of that, primarily because all three of them have channels. So I kind of wanted to see what's it like to write all three of these using similar functions. The other thing is that I wanted to explore speed. And what I found is that my C# example using tasks, which granted are not optimized. If you want to optimize for speed, you got to do raw threading, which I don't do because I hate race conditions. But so the C# solution is the slowest of the three. I would say that in my rough experiments, which I still need to formalize, the Go solution was about twice as fast as the C# solution, and the Rust example was, I think, 3 times faster than Go. It was a significant difference, and that makes sense because Rust, well, that's another story. Rust is actually optimized to kind of get as close to the metal as possible, and for example, there isn't like reference counting of objects and garbage collecting. There's no garbage collecting in Rust because you basically aren't allowed. Well, you can't. It's a long story, but the memory model in Rust is significantly different than in Go or in C#, and Go does have garbage collection. So Rust doesn't have a garbage collector because you're not allowed to do anything that would make a garbage collector necessary. Anyway, so that's why it's significantly faster. So that wasn't really a surprise. And then the Go and C# comparisons were more out of curiosity. Go is a much smaller language than C#. One thing about C# is right now the C# language, and I'll say the core libraries, the stuff that kind of ships when you install .NET in your machine, is kind of too big for anyone to really grok the entire thing. Go, I would say it's much closer to be able to grok, uh, just because the number of keywords is smaller, the number of things you can do is smaller. Some of the things are simpler, which sometimes when things are simpler, it makes it harder to implement. So there's always trade-offs both ways. But it's been really interesting to kind of explore those. I actually have if you're curious, I have a video on my YouTube channel, which is also Jeremy Bites on YouTube, which is a tour of Go for the C# developer, where I kind of show similarities and differences between Go and C#.
There was another one that popped up that seemed useful. Oh, a friend over on LinkedIn asked if you could do a quick comparison between channels and concurrent queues. And like, there's a lot of data structures in C# that kind of do the same thing, but not quite.
Yeah. Okay. So I have some really good news for you, because there's an article here that says, "What's the difference between channel and concurrent queue in C#?" Written
It's
by
our
Jeremy
ringer
Clark.
that we threw in the chat just for you.
Yeah. There you go. And so it's kind of the things that I talked about. First, the specialization, so the separate reader and writer properties that can allow for optimization. And then the other big thing is the signaling. And actually, okay, so what we've got: separate reader and writer properties. And again, you can read the details here. Separate reader, closing the channel. Again, sorry, marking the channel as complete. So that signaling part is built in, which is really important. And I know I had a difference here. There's also channel options, such as the create bounded, create unbounded, as well as there's things that you can say, I'm only going to have a single reader or a single writer. And so when you do that, there can be optimization. So I don't have to worry about threading with reading and writing. Yeah. And then, but something that's important is channel of T is not an enumerable. So you can for each over a concurrent queue if you want, and that'll work. You cannot do that on a channel. Does not exist.
Yeah. We've also used in demos, a lot of demos, what's it called? Blocking collection. Trying to remember what which is thread safe. And you can just pump it as quickly as you want to. And then you have something else that's reading it. Similar example. But you basically have a for each that never returns.
Yeah.
That never.
But you have to have
exits.
Something in there, like a shared variable to say this is done. If false, close. Yeah.
Yep. It's a good exercise in cancellation tokens. If you're not using cancellation tokens everywhere. So, but I kind of wish I knew more about channels, because I think that particular demo we would have gotten more use out of channels than we would have blocking collection. So now I got to go rewrite that demo. I learned something new. Last question, I think, for tonight. Any issues using this in a Blazor WASM app that you could foresee?
Not that I'm aware of. It's in the general, it's like let's see, let's go back to this. So the console application I was using is just a standard .NET 6 exe. So it's not .NET 6 dash something. So I would assume that it's fine. And that's actually something I've been meaning to look into, particularly because I've historically done a lot of desktop programming. So the idea of getting off the main thread and being able to write back to it is a big thing in the world I've been in. I'm kind of curious if Blazor has that same problem. I think that Xamarin and Maui do, but that's, I'm not sure about Blazor. But theoretically it should. It's just a .NET 6 thing.
All righty. Well, now's the time, folks. If you have any other questions, drop them in the chat. Lots of thanks. This was a very busy presentation. We had a good number of folks show up with us tonight. All right.
Yeah, I like to hear that. Makes me feel useful.
All right, friends. Well, I'm waiting for the chat if anyone wants to say something. All right, well, we'll go and leave it there. We've thrown out in the chat a couple times how you can get a hold of Jeremy if you want to ask him any questions after the fact. Jeremy, thank you so much for hanging out with us. You were kind of like a last minute quarterback for us. We greatly appreciate you coming in under such short notice. We'll have to put you on the list to have you back in a year or so. And I know I'll see you around at conferences as they pop up. Drew, thank you for hanging out with us this evening. We don't know who we're going to have back next month. We're still working out those details. But if you're interested in speaking, reach out to me on Twitter and we'll get you hooked up. But again, Jeremy, thank you so much for hanging out with us this evening. Thank you to everyone on Twitch, YouTube, and LinkedIn for joining us. And we'll see you all next month. Take care.